Hello, I've had a question about Unit 4, Lesson 2, and I'm looking at question number 6, and it's a graphing question. So when I look at these types of questions, first thing I do is take the first derivative. So I'll go ahead and do that. I'll use quotient rule. So we end up with this minus x derivative of that using your chain rule, like that. And it's going to be over x minus 1 to the fourth. Now on top I see that there is a common factor, so I'm going to factor out an x minus 1. Inside that would leave me with x minus 1 minus 2x over x minus 1 to the fourth. That will reduce to the power of 3. So my first derivative turns out to be negative x minus 1 over x minus 1 cubed. If I take out a negative on top, I end up with x plus 1 over x minus 1 cubed. It doesn't really matter when you get to that stage. So that's your first derivative. Whenever I do these questions, graphing questions, I usually don't do the second derivative unless I really, really have to. So I'm going to hold off there, stay at that point, and see if I need to take that second derivative. So from there, I can find a max min. So max min, so that's where we let our first derivative equal 0. So that means that the numerator will have to be 0. So that means when we look at this, our max min is going to occur at negative 1. All right, so that could be an inflection point as well. That's what that second derivative does. It says first derivative will identify max mins and inflection points. Second derivative will find inflection points. So at this point, I think I know that this is either max, min, or an IP. So I'm going to see the information I collect if I can logically figure out which it is. So next thing I will get, let's go with x-intercepts. That occurs when we let the original function y equals 0. So again, that means that the numerator will have to be 0. And there we have the location of our x-intercept at x equals 0. So I'm going to put that piece of information on there so I know we cross the x-axis at 0. Similarly, I'm going to find my y-intercept. That's when we let x equals 0. And when I do that, I find y equals 0. So that means that the x and y-intercept are at the same point at the origin, which makes sense since that's where the x-intercept was. Next, I want to take care of my asymptotes. All right, so first thing I do is my vertical asymptotes. So we let the denominator equal 0. So we let x minus 1 squared equal 0. So that means that if we look at that and solve that, there's going to be one asymptote, and it's going to occur at x equals 1. So I'm going to go to my graph and add that piece of information on. So I've kind of got an ongoing construction here of what my graph is going to look like. Next, I take care of my horizontal asymptote. So the horizontal asymptote, so when we let x go to infinity, x over, and I'm going to have to do that expansion on the bottom. So equals the limit, x approaches infinity, for x over x squared minus 2x plus 1. To do this, we divide by the largest power. So I'm going to divide everything by x squared, as we did in Unit 3. From that, my top is going to go to 0. That term goes to 1, 0, 0. And in the end, we find out that is going to equal 0 over 1, or 0. So we have a horizontal asymptote, and it is along the x-axis. All right, so put that asymptote on my graph. Now I want to find what is the value of my max or min. So I'm going to plug that value of negative 1 back into the original equation. So y equals negative 1 over negative 1 minus 1 squared. So we end up with negative 1 over 4. So therefore that point, I should have calculated at the time, is going to be at negative 1 and negative 1/4. So that will look something, -1 and -1/4. It's going to look like that. All right. So at this point in time, we can take a look at the end behavior. The horizontal asymptote tells me that my graph is going to exit either here and here, here, or here. So kind of using common sense, if we look at this region right here, I know I have to pass through 0, 0. I have to pass through my max min. No other x-intercept exists along here, which means that in order to exit the graph, I'm going to have to go like that. I have to approach that horizontal asymptote. I can't get above the x-axis again because there's no x-intercept, which means that my only choice in the other direction is to go up the asymptote that direction. Now on the other side of the asymptote, I need to know max or min, there is no max or min, so I can't cross over. There's no x-intercept, so there can't be a hump that looks like that. That can't happen. So if in doubt, what you can do is you can analyze it as approaches -1. So what does the limit look like? So this is end behavior. The limit as x approaches -1, and let's go from the positive side because that's what we're interested in, for x over x minus 1 squared. So in my mind, what I'm doing is a number, that should be +1, right? Because that's where my asymptote is. So in my mind, +1, so let's say, that's like saying 2. So if I put 2 into the equation, if this became a 2 on top of the numerator, I'm going to get a positive number. If that x became a 2, 2 minus 1 is going to be 1. It's going to be a positive number. Positive divided by a positive, it's going to result in a positive. So that means my y values dictate that the graph is going to exit here. Because I can't cross the x-axis, I know then I'm going to come down and join that particular arrow there, and that one would disappear. So that's what number 6 would look like going through the graph. So do you have to find all the pieces of information? No, but I want you to find enough pieces of information that you can come up with an accurate sketch. Because in the real world, you're probably going to use graphing technology. So I'm looking for those problem-solving skills. If you have any questions, let me know, and I'll try to help you out.